है कल
ओके कोई बात नहीं वो भी एग्जाम हो
केमिस्ट्री
वापस आ जाओ ओके
अभी तो मेमोरी क्लास रिकॉर्ड कर सो
कोई एब्सेंट हसे એવું લાગશે કે બહુ લોકો એબ્સેન્ટ છે તો रिकॉर्ड કરી દઈશું क्या बोल रहा था हाँ लाइट यस सो in the last class we have done refraction of light है ना if we recap a little bit we remember that the refractive index is equal to sin I upon sin R but it is also equal to 1 by sin C where C is the critical angle
वो नहीं कर critical angle
नहीं पता
you don't remember critical we did not do critical angle okay if you don't know this formula do you know that the velocity of light in the medium upon the velocity of light in air upon velocity of light in medium is also velocity of light in vacuum or air
हाँ ये का
है ना and this would also mean that you know that this
oh
is
my
nothing
god
but
I was not there last class exactly
तो वीडियो જોવાનો છે પર એટલા માટે જ અપલોડ કર્યો છે so you have lambda
वीडियो प्राइवेट
no
चैनल पर पोस्ट कर
हाँ તમે ક્લિક કરશો તો દેખાશે so this is lambda upon lambda in the medium मतलब wavelength changes we know that bending means wavelength changes है ना do you know this much
how is C what is C
C is the
speed
for
of light in
this
vacuum
it is yes speed of
how is that lambda
light in vacuum
lambda is wavelength
और also because there is a change in wavelength
this is the original wavelength and this is the wavelength in that particular medium right now if you remember this much let us understand something more see what is happening over here the light is bending from 54.4 to 33.3 है ना we can find out sin I by sin R should be equal to क्या होना चाहिए refractive index n right now what will happen see if the light was going from
n मिल गया है
हाँ
तो फिर यूज क्यों करेंगे यूज किस में करेंगे
अभी समझाता हूँ see if light is going from a denser to rarer medium right what happens is that the light moves away from normal है ना no matter what light it is right it is moving away from normal here the angle of incidence is 20 here the angle of refraction is 32.3 why because the light gets faster when it goes to an optically rarer medium right now let's see what happens if the angle of incidence is 33.9 the angle of refraction becomes nearly 60 है ना if I go on increasing the angle of refraction right what will happen there will be an angle of refraction where will there be an angle of refraction where this light goes so much away from the normal that it goes through the plane of separation है ना glass and air के बीच में से जाएगी it cannot escape जो 82 है if I go on increasing this will this also go on increasing है ना will there be a certain point where this angle is exactly 90 है ना try भी करिए we will not find exactly 90 in this simulation but देखो क्या हो रहा है suddenly you see that there is no more refracted ray देखो ये 40.6 है 42 पे no refracted ray
right hand
है ना so somewhere near 41 it's
the last thing I could see is 87.2
right then it suddenly vanishes है ना what is this happening देखो here there is refraction here there is no refraction then what is happening
it is reflecting
but this reflection is different in general reflection what happens
angle of incidence is equal to
It's the
angle.
same.
It is still the same. In general reflection,
All the
light
particles
is
bounce.
this. All the particles are
That's on the
bouncing.
same plane.
Same plane. This is also same plane. But in general reflection, light is going from a rarer medium and returns to a rarer medium. So light in air bounces off, comes back in air only. This is going from glass to air,
And then air to
still
glass.
bouncing off. Have you observed कि एक पानी से भरा ग्लास ले लो, है ना, और थोड़ा सा ऐसे ऊपर देखोगे ना तो उसका सरफेस, इवन दो वाटर इज ट्रांसपेरेंट, उसका सरफेस ऊपर का सिल्वर दिखेगा, एकदम ओपेक जैसा दिखेगा. हैव यू ट्राइड दिस? है ना? व्हाट इज हैपनिंग एट दैट पॉइंट? नथिंग बट total internal reflection. What is this? Total internal reflection. But before we write total internal reflection, let me explain something. Some time milega. 100% in the syllabus. So I was discussing that there is a certain angle of incidence where the angle of refraction is 90. Everybody agrees this does exist. Can we say that if the light was going from here to here, then at this angle of incidence, this will be the angle of refraction? Right now, light is going from denser to rarer.
Okay, so
Right? It has an angle of incidence as 39, angle of refraction as 74.4. Right? But if light had an angle of incidence 74.4 and it was traveling in this direction, will it retrace its path?
yeah.
Why it will not? It is still the same,
It
right?
will bend
We know.
towards the normal.
No. So what has happened? It has gone like this and it will bend towards the north.
So saying light is going from here. The incident is
If it was going from here, will it retrace the same path?
Yes.
Is what I am asking.
yes.
See,
Okay.
this is how the light is traveling right now. Right? What is governing this angle of refraction? The refractive index. So let's say the refractive index from glass to air is 1 upon 1.5. Will the refractive index from air to glass be actually just 1.5?
Yes.
Do you agree this?
Yes.
Do you agree to this?
Yes.
Do you agree to this?
But what the use of index of refraction is over here?
See,
आपने angle का.
you're saying you don't know what is the.
No, I don't understand what is the use of index of refraction.
We are trying to understand that when does exactly light stops refracting and starts reflecting. That is what we are trying to understand, right? And to understand that, આપણે શું કરીએ છીએ? આપણે એવી રીતે construct કરીએ છીએ. We are finding the exact instance when this, instead of going here, right? It passes through exactly this line. Will there be a point? है ना? Everybody understands this? This is our angle of incidence right now and this is our angle of refraction. Because it is going from denser to rarer. है ना? Because it is going from denser to rarer. Can I write sin I upon sin R is equal to 1 by n? है ना? Let's forget retracing the light. Do you agree to
What is
this?
the n?
N is the refractive index. Refractive.
How will be equal to 1 by 1? 1
One by n.
n होएगा ना.
Because see, we have always calculated refractive index when light is going from rarer to denser. So if when light is going from rarer to denser, if the refractive index is n, for the reverse path it has to be 1 by n. Makes sense?
Yeah.
Right? Now let us add some values to this 1 by n. Do you all agree that exactly when this is 90 degree, can I write denominator as sin 90?
Yeah.
है ना? Now for numerator, is this a special angle at which no refraction is taking place? In fact, the ray of light passes through the plane of separation. What do we call this? This yellow line. What is this? Plane of separation. It's neither in air nor in glass. It is exactly on the plane of separation. है ना? So what is this known as? Critical angle. Angle at which no refraction takes place is known as critical angle, or for the angle of incidence where the angle of refraction is 90, that is also critical angle, है ना? So can I say कि critical angle लिख दिया मैंने sin c is equal to 1 by n. Now if you remember a little bit of trigonometry, what is the value of sin 90?
Sin 90 is 1.
Perfect, sin 90 is 1, all of you are correct. So sin c upon 1 is equal to 1 by n.
So 1 by n
Then
becomes
sin
sin
equals
c.
to n.
Sin c is not equal to n. N
That
is
is
equal
by
to,
1.
you will reciprocal both of the values, no? Does this formula now make sense to you?
Yes. So then what's the total internal?
We will come to that. This is the first thing I want you to write. Okay?
So here n is what?
Refractive index.
Absolute.
PHET. Guys, I would suggest, this is like, even if you think you were in the class, na, if you look at the videos very quickly, like you can skip most of the part and still have a small revision, right? तुम्हारा ही फायदा है ना? अगर और कोई क्लास का है, then you can also like see. Generally, what I do is that I am teaching the same syllabus over and over again, है ना? So what I try is कि in every batch I will keep the approach a little bit different, so it remains interesting for me also. So even if you think कि I was in all the classes for waves, but if you look at recording, you might find something else, है ना? Although the conclusion will always remain same, but there can be different examples. एक advantage ये भी है कि someone else is asking doubts that did not even occur to you. तो वो भी सुन सकते हो, है ना? I do not edit the video in any way. I just upload it as it is. Okay? And the video is not on YouTube. It is just for the kids that are here. वो private नहीं है, unlisted video, right? So it goes to only people whom I have provided the link.
So n is refracted index.
And refractive index.
What is critical angle?
Critical angle is the angle for which angle of refraction is 90 degrees.
90 degrees.
Angle for which?
The angle of refraction,
So what is C?
critical angle.
For which?
The angle of refraction is 90 degree or right angle.
What is the plane known as? This plane.
Plane of separation.
Plane of separation, where the refracted ray passes through the plane of separation.
For which specifically?
Critical angle. Angle of refraction. Which is 90 degrees.
Who is absent? Kaya. Anyone else?
No.
Plane of separation is the is where the refracted ray.
It travels, the refracted ray travels through the plane of separation. What have you written?
Plane of separation is where the refracted ray.
Travels.
Separation chest.
Exact line, अभी उन्हीं बच्चे नी जो exact line છે ને That is known as plane of separation.
It's neither in the denser medium or in the rarer.
सही बात. Perfect. करूँ erase?
So this only happens when it goes from the denser medium to the rarer.
Because if it is going from rarer to denser, it is already moving towards the normal. है ना?
Because sir, what if when it moves towards the normal it reaches 90? तो वो
Will
straight
go
line.
by straight line. पर फिर भी क्या है देख, अगर ये सेपरेशन प्लेन है और ये नॉर्मल है तेरा, ठीक है, तो वो रे तो ऐसे जा रही है ना, ऐसे आके सॉरी इसमें बैक नहीं है तो
It's where the refracted ray travels.
ठीक है, जो रे ऐसे आ रही है वो एग्जैक्टली ऐसे चली गई,
हाँ.
उसका कोई स्पेशल नाम नहीं है.
That will not work.
क्योंकि यहाँ पे देख, यहाँ पे एंगल ऑफ रिफ्रैक्शन 0 है ना, साइन 0 की वैल्यू क्या है, तो कोई लॉजिकली इम्पोर्टेंस नहीं है इसका, ठीक है. और वैसे द एंगल एट विच r इज इक्वल टू 0 एक ही एंगल है ऐसा, i इज इक्वल टू 0, ठीक है. देयर इज नो अदर एंगल फॉर विच r इज इक्वल टू 0, ठीक है. इफ यू हैव रिटन दिस, डू आई गो बैक टू द फॉर्मूला शीट, है ना, ठीक है. Right. So now that you know all this, can I write this is equal to 1 by sine c? Now can I write refractive index is equal to 1 by sine c? Do all of these formula now make sense to you? We will use these formulas in the worksheets, ठीक है, and in your questions. I will teach that to you when we come to it, है ना. थोड़ा सा भी theory पढ़ लेते हैं, right? Let's go back to the simulation. I need to teach something more. Now, if you observe this diagram, right, beyond critical angle, अच्छा वैसे I can also find, not just me, all of us can find critical angle. Now I know that n is equal to 1 by sine c, and for air to glass the value of n is 1.5. Can we all find out the value of critical angle?
Why you not 1.5? Oh.
Okay, it is a standard value, it remains constant. Whenever light goes from air to glass, the refractive index is always 1.5.
But sir, मैंने कैलकुलेट किया था कुछ और वैल्यू है.
कब कैलकुलेट कर रहा था? चल ये कैलकुलेट कर लेते हैं. So you will write sine 79.3 because we are finding angle refractive index for air to glass. So sine 79.3 upon sine 40.9. Tell me what is the refractive index over here?
1.500.
Exactly. So 1.500. So can I write it as 1.5? है ना? Now, can we use the same formula? So, n is equal to 1 upon sine c. Can I write sine c is equal to 1 upon n, and c is nothing but sine inverse of 1 by 1.5. Here the value of n is 1.5. मेरे को फाइंड करके बताओ what is the value of critical angle. I will give enough time to write, don't worry.
41.81.
So the value of critical angle for glass is 41.8 degree. So if the angle of incidence for the light that is trying to come out of the glass, if the angle of incidence is greater than 41.8, what will happen? Let's see. Okay, what happened?
सर तुम बीजा हत्ती कर
हमें देखते हैं. तो मैं भी ऊपर ले आना चाहिए. Right? I'm lefty, so it's intuitive. I'll try, but lefty तो intuitive.
तो
What is
41.8 exact होगा.
तो the angle of refraction is 90 degree.
इलेनी आगे कर सकते.
Right? Any angle greater than 41.8 will result in reflection. है ना? What will it result in? Reflection. It is known as, पहले सुन लो, it is known as total internal reflection. Total because all the light gets reflected, है ना? Internal because it goes back into the denser medium.
But so where does it go into the rarer medium? Plane of separation में रहता है ना?
पर उससे ज्यादा एंगल हो तो
Stays in the medium होगी ना, same medium.
अरे मेरे भाई देख 41 क्या एंगल था अपना 41.8 तो 41.8 से ज्यादा हुआ 41.7 पे 86.5 है 41.8 से ज्यादा हुआ हियर अपना वैल्यू आ रहा है 43.1 तो क्या हो क्या रहा है रिफ्लेक्शन राइट
41.8 मैक्सिमम आया तो 1.7 पर 89 जो कुछ ना
हसेस है you can use sin I by sin R
तो ત્યાં
to
86
find out
દેખાડે છે
sin નો રેશિયો proportional એવી રીતે નથી ને right we have to always use sin I by sin R to find out the value of n right because 1 degree increase does not mean so difference between sin 47 and sin 48 is not 1
हाँ it's a lot
right it's a function so it might have different values basically what is happening total internal reflection also written as TIR why is it reflection obviously getting reflected why it is known as internal because it is going back into the denser medium why is it known as total because all the light none of the light is refracting all the light is getting reflected make sense if the angle of incidence if the angle of incidence is greater than critical angle for light going from denser to rarer medium
from light
for light going from denser to rarer medium going traveling incident in the denser medium towards the rarer medium
For light going?
But
from denser to rarer medium
फुल वापस 180 करके वापस नहीं आ सकते ये साइड
कैसे आएगा भाई
सर क्रिटिकल मस्ट बी क्रिटिकल
CRITICA
अभी ये साइड कर दो ग्रेट तो ये साइड कर दो तो राइट साइड कर
तो भी ऐसा ही होगा
नहीं
how does it matter कि राइट साइड पे या लेफ्ट साइड पे
फुल वो
देख सिंपल ऐसा समझ कि बॉल है ना तू यहाँ से फेंकेगा तो ऐसे रिफ्लेक्ट होगा वहां से फेंकेगा तो ऐसे रिफ्लेक्ट होगा इट डज नॉट मैटर व्हाट साइड आर यू
अब तो ये साइड पूरा लेके नहीं तो वापस भी साइड हो जाएगा
हाँ सो उस पे आते हैं थोड़ी देर में उस पे और थोड़ा देखते हैं कैसे क्या होगा राइट the light reflects back into the denser medium the light reflects back into the denser medium this is known as total internal reflection
टोटल इंटरनल
reflection यहाँ तक सब clear to what I'm trying to explain does it make sense am I okay
So there is no way that the light rarer medium that touches the normal right?
not in this case but let's say
बीजा वाला case
if it is going from air to glass right if I move this in this form let's say I move it here है ना so it's going like this, but I move it here, it's going towards the normal. है ना? This is what I was explaining, that when it is going from rarer to denser, here the angle is decreasing, so slowly it will reach 0. But the only angle of incidence where the angle of refraction is 0 is 0. Right? Sine function is a ratio of sides. So again, sine 46 and sine 47 का difference one no nothing, अलग value है. You can do that in your calculator. Sine 47 minus sine 46. It is not 1 unit, right? And the difference between sine 46 and 47 is not equal to the difference between sine 45 and 46. Right? That ratio keeps on changing. So if you see, you can clearly see here. Right? देखो यहाँ पे क्या हो रहा है? What I am trying to explain is 49.6 है, and the angle of refraction is 30.5. है ना? Let's change the angle of incidence. Let's make it 42.1. So this changed by how much? 6-7 units. This changed by 3 units. है ना? Now let's change this by 6-7 units more. 36 पे we have reached. है ना? Nearly. This changed by even less. So that change is getting smaller and smaller in such a way that when you reach a very small value, change here is smaller, much smaller. Change is observed in angle of refraction. This is a sinusoidal graph. Sin theta can have a graph which is a sinusoidal. Right? So this is what I am trying to explain. So this is 12.8, this is 8.5, right? Now if I decrease it by, let's say 11.5, तो ये कितना हो गया? 7.6, है ना? So this decrease is getting smaller and smaller, such that this will become 0 only when this is also 0. So the angle of incidence is, the angle is 0 only for 0.
And what do you call this?
This is no refraction taking place. We've already done this. No refraction takes place when the angle of incidence is already 0. The ray is traveling it's already traveling through the fastest path possible. है ना?
आओ कोई situation में था?
था ना क्या था है?
ना like real life.
हाँ था ना. For example, let's say this is a glass block. Okay. Now what will happen when I look through a glass block like this? If this is transparent, तो नीचे जो handwriting होगा, it will appear raised, है ना? अभी हम वही देखने वाले हैं next. But if I look exactly from here, it will not appear raised. Why? Because no refraction is taking place, है ना? Let's have a look. Okay. That is what I was planning to teach next. स्कूल में क्या हो रहा है?
वो ये वाला ही सिखाया,
Dance.
सिखा रहे हो।
Dance.
लास्ट फिजिक्स में सब कुछ कर। हम जो अभी सिखा रहे हैं
थैंक्स नहीं तो ठीक है, डांस चल रहा है ना बेसिकली.
वो सर अभी स्कूल में ट्रिग्नोमेट्री भी नहीं सिखाई, किताब में जो कॉर्नर सिखाई मैम वो भी नहीं सिखाई.
ये वर्ष में पूरा ट्रिग्नोमेट्री एक वीक में खत्म कर देंगे.
पर वो एक वीक के बाद ही सिखाएंगे ना मैम फिर.
नेक्स्ट वीक.
अरे मैं क्या बोल रहा हूँ?
पहले डिफरेंशिएशन तो करने दो.
क्या सिखा रहा था मैं? रेज्ड ऑब्जेक्ट्स ना.
हाँ.
जैसे वाटर में कॉइन ऊपर गिरता है.
इधर सिमुलेशन था तो सही मेरे भाई. अभी we are going to find out if it is still available or not.
No.
अरे इको क्लास मध्ये लॅपटॉप आवाज नहीं आता
मिल रहा है अलर्ट तो ना 4:15.
नहीं है तो लेट्स ड्रॉ डायग्राम व्हाट विल हैपन. और टेक्स्ट बुक है सबके पास?
हाँ.
निकालो टेक्स्ट बुक में एक पेज. I will show you. Yes. Look at page 145.
स्कूल वालों के पेंसिल वाले
View.
तो स्कूल वाले
हाँ, spoon appears bent inside a
तो
glass of water. है ना? Objects appear raised that are at the bottom. When you look at them at an angle, because only then bending is taking place. है ना? When you look at them just ऊपर से, so no bending is taking place. Right?
yeah
Now, if you understand this much refraction, let us understand two more refraction happening through a glass block, जो तू थोड़ा सा पूछ रहा था, and a prism. Right? Both of them have a little bit difference in their refraction pattern. क्या होगा? Let's see. Right? So, let's suppose that this is a glass block. Okay, and light is passing through this glass block like this. Okay, let us also draw normal. Yes, white ले लेते हैं like normal. Okay, might take some time. Be patient with me. ठीक है. What should happen to the angle of refraction? It should be
towards the normal.
right, because ये glass है and this is air. So let's draw towards the normal ray. Is this towards the normal?
Yes.
Now let us also draw. हाँ, refracted draw कर लेते हैं. Then we will draw the normal. What will happen? It should move away from normal.
Yeah.
है ना? Now to understand how does it move away from normal, can you also intuitively understand this also? कि જેટલું અહીંયાથી આ bend થાય છે, right? It's bending, let's say,
It will bend the same amount here.
away, है ना? तो let's draw that, right?
They will be parallel.
What you will, yes. Let's say this is ray 1, this is ray 2, and this is ray 2. 1 is parallel to 3.
Yeah.
है ना? And in fact, right, let's draw a yellow ray over here, ऐसे. Right. Okay. This is a small shift, है ना? This is known as lateral shift. तेरे लिए. What has happened is that the object, right? If the light is traveling from here to here, let's say for example, there is a coin over here. So the light travels from the coin to our eyes, only then I can see the coin. So it will appear somewhere where it is not, because your eyes and your brain cannot comprehend that refraction is taking place, right? So your eyes will think that the coin is actually over. So what happens? It appears somewhere else, है ना? तो जनरली ऊपर दिखेगा, है ना? ये क्या हो रहा है? ऐसे शिफ्ट हो रहा है, lateral shift हो रहा है, right? So it appears a little raised. Makes sense?
Right and left दोनों
क्या?
lateral shift right.
दूसरे साइड से देखेगा तो ऐसे दिखेगा, है ना? You can make a mirror image of this thing. This makes sense, guys? है ना?
Lateral shift में वो एक
But,
direction अपना.
Map.
Parallelly shifting to left or right. Yes sir.
मैंने बोला था कि to see an object it require multiple rays of light.
Yes, it will require 2 rays of light. I'll come
That's
to
why
that.
we are shifting from left to right.
उसमें light
Left or right.
From left.
सही बात है भाई मैम की एकदम परफेक्ट बात है कि there are at least 2 rays required to see an image.
To see the light also.
Any image. Right? Here you should be able to say that this angle of incidence, now there cannot be 2 angle of refraction, है ना?
Yeah.
So angle of incidence, angle of refraction, and this is known as angle of emergence. Emergent ray. Ray that comes out of this object, of this transparent object, है ना? Is emergent ray. So angle of incidence and angle of emergence are equal in this. Clear?
Yeah.
Why does this happen? This happens because the normals are also parallel to each other. है ना? The normals are also parallel to each other, which is why all of this happens. You can note this down. आराम से लिखो, properly लिखो.
Sir, a law refraction or refraction?
Huh?
This is a law or
No. This is logic. This is an extension of the understanding of the law that sin I by sin r is always equal to refractive index. मैथमेटिक्स से करेगा ना तो भी यही आंसर है.
So lateral line would shift to definition बोला.
Image shifting towards left or right of the original image.
so ऊपर कैसे दिखता है राइट और लेफ्ट?
हैं?
लाइट और लेफ्ट शिफ्ट में तो ऊपर क्यों दिखता है?
अभी सेकेंडरी ड्रॉ करके जब इमेज दिखाऊंगा ना तो ज्यादा पता चलेगा. एक एक करके बिल्ड करते हैं, पूरा कर देंगे. भाई कल का टाइम इज नॉर्मल टाइम.
Chemistry.
नॉर्मल टाइम.
I will be there on Thursday.
हाँ. Again, if I think Kayan will also be working, so I record.
Sir, Eno.
Emergent ray and angle of emergence. EME. Emergence. देखो अपने बोर्ड में ना नेमिंग इतना ज्यादा इम्पोर्टेंट नहीं है. आई डोंट थिंक तुम्हारे टेक्स्ट बुक में कहीं भी इमर्जेंट लिखा है.
Emergent ray and
एंगल ऑफ इमर्जेंस. राइट. मैं ये बता रहा हूँ सो दैट यू नो दैट दे हैव डिफरेंट नेम्स.
So ऊपर जैसा
confusion था है तो से E लग.
So फिर ऊपर जैसा.
ओके.
चीज उस प्लास्टिक चिपका हुआ है.
क्या हो रहा है?
हाँ जी.
चीज उस प्लास्टिक इधर वो साइड आगे ये.
Thank you. Okay. Now let's look at what happens through a prism. What is a prism, by the way?
Oh, glass. Is that triangle वाली वस्तु?
3D
right?
mod.
हाँ.
What is a prism?
3D triangle. Yeah, and when you see light, you
3D
see it's a
triangle.
rainbow.
Multiple triangle.
Glass pyramid.
3D.
Okay. Maths में कोई पूछे what is a prism तो क्या बोलोगे?
3D triangle. 3D triangle. Glass. Glass 3D triangle.
A triangle.
3D shape.
A place,
It's a 3D shape, okay.
a
Glass.
place where three faces of a triangle meet at one point.
There can be a hexagonal prism also. There can be a rectangular prism also.
Where all the faces meet up to one point and have a
Yeah,
triangle.
1 point पे कैसे मिलेंगे?
Prism ऐसे.
Faces तो ना वो लंबा वाला.
That is pyramid. What you're saying?
That's a pyramid.
So what is a prism?
When the face is same throughout.
Yes. It has a
That-
regular cross section.
Regular
Yeah.
cross
That
section.
is a prism. है ना? तो
Even cylinder is a prism. Huh?
it does not have plane surfaces. Prisms need to have plane surfaces. Right? That is why it is cylinder. Okay. Why is this known as triangular prism? Because
It's shaped
इसका
as a triangle.
Triangular.
cross section triangular. Right?
It's
So this can be a very long shape, but the two faces, the two cross section we can see are triangular. This much makes sense to
Sir,
you.
but when a glass prism and white light goes to glass prism, it looks rainbow at night.
So
Why?
spectrum क्या है?
Dispersion.
Why?
Dispersion.
Let's see why that happens, right? That is why we are
सेंटर क्या होगा ट्रायंगल का ये प्रिज्म जो
इसका
बना है
triangle का optical center नहीं होता मेरे में,
प्रिज्म का जो बना है वो
नहीं होता. Optical center इन चीजों का नहीं होता. Optical center सबका नहीं हो सकता. Right? Is this normal to this face of the prism?
Yes.
Is this normal to this face of the prism?
Yes.
इधर तक किसी को कोई
This is just light coming.
this is
Normal,
not even
sir.
light, this is normal.
अच्छा, normal.
90 degree to the surface of the prism. है ना? Everybody agrees to this. इसमें किसी को कोई दिक्कत नहीं है ना? Sure?
Yes.
Okay. ठीक है. Now let's take a ray of light. Okay. Let's say there is a ray of light traveling like this. Where will it bend?
Away. Towards.
It is going from air to glass, so it will bend
Towards
towards the
the
normal. Now where is it going?
Away.
Away.
Away from the
Away from.
So what will happen?
Angle.
Won't they be parallel?
Why?
Only
Even the normals are not parallel.
Okay.
है ना?
पर भी रिफ्रैक्ट नहीं हो सकता
कैसे होगा? See, whatever refraction we have seen, light comes from this side, crosses the normal, goes to other side.
So here this is the
Exactly same is happening over here. है ना? Light is coming from left of the normal.
हाँ
After refraction is going right of the normal. Here it is above the normal. After refraction has to emerge from the below the normal.
Yes.
यहाँ तक अब पक्का स्टेज वाइज करेंगे. समझ में आ रहा है सबको? श्योर?
Yeah.
ओके. नाउ थोड़ा एरो ड्रॉ कर देते हैं, so we know where is the light coming from. Now what has happened over here is that in glass block the light got bent, but then again because the two surfaces were parallel to each other, है ना? Let's also visualize this. Because these two surfaces are parallel to each other, these two normals are parallel to each other, and therefore these two rays are parallel to each other. So how much ever it bent, it again came back to that direction. है ना? Make sense? But what has happened over here? It has bent once and then bent
Again.
now. Right? It is bending. That ray was also bending twice, but the second bend was
Parallel.
normal
Parallel to the first ray.
But the surfaces aren't parallel to each other. That's why the bend.
that's why it
Okay.
goes from here to here. है ना? So that ray was not deviating. The two rays were parallel to each other. Here, can I say
But this is more common phenomena, right?
both of them are equally common? Can I say that it is deviating this much?
Yes.
मैथमेटिकली हमारे लिए इसका कोई इम्पोर्टेंस नहीं, मैं सिर्फ दिखा रहा हूँ कि इसका पाथ इतना ज्यादा चेंज हो रहा है. उसका पाथ चेंज नहीं हो रहा था. इट वाज रीगेनिंग इट्स पाथ. It was still going in general direction of the same path. Here it's not happening. Here it's path.
Again like this.
Sorry.
Like the first ray. Is that why it's not going again?
Huh? Right? It's bending and then bending again. both the times it is still obeying the same law of refraction. कुछ नया नहीं है. नया क्या है? That the faces of this triangle are not parallel to each other. है ना? So it is deviating from its original path.
Yeah.
है ना? अभी ऊपर एक फॉर्मूला लिखवाया था कि लैम्बडा अपॉन लैम्बडा m is equal to n. ये फॉर्मूला एक्चुअली टेक्स्ट बुक में कहीं नहीं है. But if you write this, you will have an easy time understanding what is happening with prism. ठीक है?
Yeah.
Now,
प्रिज्म नहीं लिख रहा होता.
Ama M should sir.
m is the wavelength of that light in particular medium. We have understood this in waves that when refraction takes place, the wavelength changes.
સર એટલે સાઉન્ડમાં આખો અલગ
Light માં भी अलग હશે બેટા.
ને આ લાઈટનો જ છે ને તો સાઉન્ડમાં આ વસ્તુ અલગ
આ બી જ થશે. But sound is not made up of 7 colors.
So this is the only difference between a prism and a rectangular slab.
Yes.
Slab.
Yes. Okay. Does this make sense? अच्छा ये फॉर्मूला नहीं लिखना है. अभी जो समझा ना थोड़ा सा I am explaining based on formula, but I am trying to make it easier, which is why we are using the formula to make more sense. But you don't need to remember the formula. Okay? Acha. Now all of you know what happens. Tell me what happens.
So
Light
because of the
gets
angular
dispersed.
deviation, light is split into different colors.
Light disperses to different colors. This phenomenon is known as
Dispersion.
dispersion. में colors क्या बनते हैं?
સ્પેક્ટ્રમ
Very
No,
nice.
IGCSE.
This is known as
Spectrum.
spectrum. Now I am going to take a risk and write. है ना मेरे को पता था नहीं.
વિબ્ગ્યોર
Your.
Don't you say Royji Bear?
In the book it's Royji Bear, but it should
It's
be
the same thing.
ये ऊपर से नीचे लिखो.
Exactly.
None of these two words have actual meaning. Does not matter. है ना? Vibgyor. What does this mean? If now you understand bending of light, now you understand deviation of light, what will you say? You will say that the violet light deviates the
Most.
and the red light deviates the
Least.
है ना?
हाँ.
Yeah.
Why does it disperse? Because the light is deviating. Right? Now each light has a
And
different
angle of
wavelength.
Yes.
Yes, each light has a different angle of deviation. But why? Because each light has a different wavelength.
Red has the most.
Red has the
Least.
Violet has the most.
so the one that has the
Most
Most
wavelength will be
wavelength is the
the
most dispersed.
will bend the most.
So will deviate the most.
Deviate the most.
It has the most.
Right? If you want to know what is the wavelength, you can go to your textbook, look at topic 3.3. 3.3 के first page पे आ जाओ. You have page 160. I'll give you enough time. This is the last topic. Okay?
160.
Page 160. Good question. Now you look at page 160. You will find कि देखो यहाँ पे अल्ट्रावायलेट एंड इंफ्रारेड
Yes.
है ना, विजिबल लाइट का एकदम छोटा सा स्पेक्ट्रम है. नाउ नीचे दिया हुआ है वो उसका वेवलेंथ है. Now you see that 0.4 micrometer is wavelength of violet and 0.7 micrometer is the wavelength of.
Infrared.
So what does this mean? This means contrary to what we just discussed. The one that has the greatest wavelength bends the least.
Sorry.
है ना 0.7 है रेड का. The one
It's the least.
है ना sure
Sir, આ 0.7 ની નીચે શું કયો symbol છે?
micrometer.
ઓનો symbol આવે.
हाँ. Right? So the one that has greatest wavelength. So let's write it here. Greatest lambda bends the least. Okay? So
Greatest wavelength bends the
least beta.
And
What did
yeah,
we see in the
The
textbook?
least one should be red color.
हाँ. So red has the longest wavelength, it bends the least. Violet has the shortest wavelength, so it bends the most.
So then violet deviates the most.
Deviates the most. Right? लिख लो पूरा ये, है ना? Take your time.
सर मोनोक्रोम
कुछ डाउट्स हो तो पूछो भाई. मोनोक्रोमैटिक मीनिंग द लाइट और द वेव दैट हैज जस्ट वन सिंगल फ्रीक्वेंसी. सी यहाँ पे क्या है कि वायलेट के पास अलग फ्रीक्वेंसी है ना, इंडिगो का अलग फ्रीक्वेंसी है, ब्लू का अलग फ्रीक्वेंसी है. सो इफ देयर इज अ लाइट विच हैज वन सिंगल फ्रीक्वेंसी, उसको मोनोक्रोमैटिक लाइट बोलते हैं. ठीक है.
और सर आपने मैं दो रे के साथ बनाऊंगा.
अभी बहुत बड़ा चैप्टर है भाई, बनाएंगे.
क्या